Good afternoon. I'm Hugh Dyer, an Associate Director in RSK's Geosciences business. Welcome to the November edition of our 2024 series of Down to Earth webinars. These sessions cover a broad range of subjects through the year and are available afterwards on our YouTube channel alongside previous talks. Our talk today will focus on how RSK Geosciences works to support sustainability and climate change resilience together with energy decarbonisation within projects and with our clients. But firstly, a brief note on housekeeping during the talk. All attendees' microphones are automatically muted through the webinar. During the presentation, you can post questions online and there'll be a Q&A session at the end of the presentation. So please get those questions posted and then we can pose them to Tom at the end. We'll answer as many questions as possible. Those that can't be answered due to time constraints will be answered after the webinar. And shortly after the webinar, you'll receive a link to a short survey. So if you could take a few minutes to provide feedback, please do so we can improve on future webinars. Now, please let me welcome our speaker today. Tom is a director of RSK and part of the leadership team for RSK Geosciences, leading on sustainability. Tom has over 25 years experience in assessing contaminated land and has wide experience of advising clients on land and waste management and is a Silk and chartered scientist. Tom is also deputy chair of the Silk board and recent past chair of the Silk professional and technical panel. So I'll hand over now to Tom to outline how Geosciences supports our clients with managing sustainability, energy decarbonisation and climate resilience within their projects. Thank you, Tom.
Thank you, Hugh. And I'm now going to turn off my webcam while we do the presentation. So thank you very much, Hugh, for that introduction. I'm going to talk to you over the next 25 minutes or so about the elements on this slide. So really starting off with introduction to Geosciences for the future, and then moving on to how Geosciences contributes to sustainable development and other current challenges that we face as a society. And talk about how we're trying to make Geosciences projects more sustainable. Talk you through some project case studies to illustrate that and our contributions, and then finish off talking about some of our key future challenges. And at the end, we're going to have a Q&A, as Hugh mentioned. So starting off with Geosciences for the future. This excellent poster produced by the Geological Society highlights the many ways geoscientists are crucial in meeting society's future challenges, be that through the United Nations Sustainable Development Goals, or SDGs for short, the Paris Agreement to avoid dangerous climate change and increasingly to adapt to it, and other important policies to protect the environment and ensure the availability of vital resources for all. I've highlighted some of the relevant aspects that I'm going to talk about today. And in addition, there are important links in terms of soils, both in terms of managing and conserving an important resource, supporting beneficial reuse of brownfield lands and other degraded land, and supporting efforts to enhance biodiversity to respond to the nature crisis. But first off, how is sustainability being approached in RSK? Well, RSK launched its Second Nature 2030 sustainability strategy just about a year ago. And the overarching goal of this is to raise our ambitions across 5 material topics: our people, our value chain, society, and the environment. And these reflect the responsibilities that we owe as a business to our widest group of stakeholders, supported by appropriate finance and governance structures. All businesses within RSK, including Geosciences, have an annual ESG, or environmental, social and governance plan, with associated key performance indicators for each of these 5 areas. And another important element of Second Nature is aligning our work with the UN SDGs so that we can clearly demonstrate how we are contributing to this locally and globally. As a prominent UK-based land assessment and design consultancy, RSK Geosciences' vision is to provide industry-leading site assessment services to our clients to achieve more sustainable and climate-resilient development and to support decarbonisation and nature-based solutions. As I'm going to illustrate in this talk, we're at the forefront of developing and implementing this in the sectors where we operate. As well as integrating sustainability considerations into our existing services, we're developing newer services such as sustainable soils management, ground carbon assessment, and climate risk and resilience for geo-based hazards. I don't have time to talk about all of these today, but I'm going to cover some of them in the following case studies. Before I get into that, it's worth talking a little bit about our carbon footprint versus the climate shadow. Our carbon footprint relates to our emissions associated with travel, office management, waste materials, and our supply chain, also referred to as scopes 1 to 3. Whereas our climate shadow is the actions that we take, but cannot always measure, that impact and influence people and our clients in a climate positive way. And the climate shadow is a concept coined by writer and climate journalist Emma Patty to better understand the impact a person or a business has on the climate emergency. In her work, she poses the question of whether a climate scientist flying to conferences on climate change issues has a bigger impact than a marketing executive who travels less but is working in a sector associated with high emissions. If you look purely at the carbon footprints, the marketing executive has a lower climate impact owing to the regular flights taken by the scientist. However, intuitively, we know that the climate scientist is likely to have a greater positive impact overall, even if this is not as quantifiable. So the climate shadow is the effect of all actions we make as a business, not just how much gas we use to heat buildings or how far our company vehicles travel, but the work that we do, decisions we take, and the actions that we make happen. So our climate shadow presents opportunities to make significant contributions to sustainability as a business. Concurrently, we must reduce our carbon footprint and our other impacts in every way possible. This slide summarises what we can positively impact through our work. On the right-hand side are our internal business elements, which I'm going to come on to in a later slide. But on the left-hand side shows our contributions to sustainability through our project work, which encompass 6 main areas: circular economy, sustainable development and net zero, nature positive, reduced pollution risk, climate risk and resilience, and energy decarbonisation. And in the following slides, we've linked these to the equivalent UN SDGs and to our project services. So starting off with SDG 6, clean water and sanitation. So work we do on soil and groundwater remediation supports that directly, as well as hydrogeological assessments such as dewatering, discharge and permitting type assessments. On SDG 7, affordable and clean energy, we directly support solar and wind development, as well as battery storage developments. And through our sister brand Carbon Zero Consulting, which forms part of Geosciences, we also undertake our ground heat related projects which support heat decarbonisation. Our SDG 9, industry, innovation and infrastructure, we undertake design and assessment of geo-based aspects for infrastructure projects. We undertake environmental and waste permitting support, and we undertake and develop innovative project solutions. On SDG 11, our work on sustainable design, materials reuse and ground carbon assessment relates very much to circular economy. We support the beneficial reuse of brownfield land, which I'll come on to one of the case studies. And increasingly important to look at climate change resilience and adaptation in geotechnical design, as well as for land contamination assessment and remediation. So that obviously also relates to item 13, climate action, where we're seeking to integrate climate risk and resilience into geoscience assessments and design, and also to support the drive to net zero, measuring and reducing embodied carbon in construction through ground carbon assessment and through effective design. And finally, in terms of SDG 15, life on land, we support regeneration of brownfield and other degraded land, including through land contamination assessment and remediation. We support sustainable soil management and reuse, which I'll talk about a bit more in a bit. And finally, we're increasingly getting involved in supporting biodiversity net gain and adoption of nature-based solutions, which are becoming increasingly important and prominent. So what about our business-related impacts? Well, these cover three main areas: staff engagement, social value, and reducing our own business emissions. Staff engagement on sustainability issues is really important, and we do this through providing annual plans and a longer-term strategy through to 2030, provide regular updates to our teams, and provide opportunities to participate. We also hold an annual sustainability stand down for all staff, giving time to engage and discuss current sustainability issues and initiatives. We also encourage staff to undertake social value activities, including acting as STEM ambassadors and participating in local community volunteering activities. And we've made a commitment to give all of our staff 4 hours of work time to spend on those types of activities through the year. Our main carbon impacts as a consultancy-led business come from travel, as well as for office heating and lighting, and through our supply chain. Much of our project work is site-based, so this is difficult to reduce significantly, and it relates back to what I was talking about in terms of our climate shadow. We do have a KPI this year in our ESG plan to reduce our non-project travel by 10%. And for project travel, our current focus is on optimising it through efficient planning and resourcing from our nearest local office, use of telemetry for remote monitoring where applicable, and use of non-intrusive techniques such as geophysics, which I'll talk more about. We're going to be increasingly engaging with our supply chain on measuring and reducing emissions, especially for projects involving field work. For site investigation projects, gathering carbon emission data for aspects such as fuel usage on site is not yet undertaken routinely. So this is something we're looking to implement to meet both RSK and increasing client requirements. A few clients specify the use of lower carbon alternatives, such as hydrogenated vegetable oils rather than diesel. But this is more expensive currently, but it's anticipated to become more common in future. And longer term issues such as the viability of electric plant or other alternative fuels are likely to become important. Other important issues in terms of emissions are reducing waste generation on site and in our premises through applying the waste hierarchy, and reducing single-use plastic in site investigation projects, which will be a challenge to the current status quo. An overarching approach to improving sustainability on projects is adoption of sustainable management practices, or SMPs for short. So what are SMPs? Well, these are common sense actions that can be implemented at any stage in a project to improve its environmental, social, and or economic performance. They cover a wide range of tasks and processes involved in delivering a project, and they can improve the sustainability of project delivery or help our client achieve a more sustainable outcome. The SMPs were originally developed by Claire with support from RSK staff, and the aim was to demonstrate and promote best practice in sustainability on land contamination projects. And in RSK Geosciences, we've applied the SMP tool on certain client contracts for many years. We've now developed it further as a bespoke tool for use across the full range of geosciences projects, and we're currently rolling this out across our business. The use of the SMP tool provides an overarching approach to supplying sustainability at a project level, and also represents a great way to measure and demonstrate the positive impact we can have through our work. And interestingly, the revised version of BS 10175, Investigation of Potentially Contaminated Sites Code of Practice, which is currently out of consultation, also advocates the use of SMPs, so we may see greater industry adoption of this soon. Another way we're looking at to make geosciences projects more sustainable is through wider use of non-intrusive techniques such as geophysics. We're fortunate to have this capability in-house, and one of the leading teams within the country sitting within geosciences. So how do geophysical survey tools gather information? Well, typically there's two types. There's surface geophysics, which cover relatively large areas but relatively shallow. And there's profiling geophysics, which are deeper and obviously look to join gaps between ground investigation locations. Using geophysics on site does not necessarily mean reducing the scope of our investigation, but it certainly helps us to better target where we investigate and provide coverage not achievable with standard intrusive techniques, thereby optimizing the below ground works. And this is particularly the case on brownfield sites, and the example on the right there for a previously developed site, industrial site, which had a very large number of subsurface obstructions, and targeting those and associated sources was a really important part of the intrusive investigation. There's a number of health and safety and environmental benefits gained from undertaking non-intrusive works. These include a reduced need to break ground, leading to a lower risk of service strikes, less nuisance in terms of noise, dust and odour, and less waste generation. And using geophysics can lead to reduced carbon emissions through better data acquisition and improved targeting of site investigation locations, thereby avoiding multiple mobilisations. And when we compare carbon emissions associated with geophysics versus intrusive investigations, we can achieve large savings. For example, a recent study that was published in GE last year found that a typical site investigation comprising 10 boreholes and 10 trial pits produced about 600 kilograms of carbon dioxide equivalent for mobilisation of plant to site, 800 kilograms for drilling works, 400 kilos for trial pitting. Whereas for geophysics, the only associated carbon emissions are travel to site, which is typically the order of 100 kilograms per site, obviously depending on mileage. So if we can optimise site investigation, there are potential savings to be had there. So I'm now going to move on to discuss 3 recent case studies illustrating how our project work contributes to sustainable development. The first case study I'm going to talk about relates to beneficial reuse of brownfield land. This relates to assessment of a 5-hectare former sawmill and timberworks. RSK Geosciences was originally commissioned by a local authority to undertake an assessment of legacy contamination issues. The site was operational for 100 years from the early 20th century, and since closure and site levelling, natural revegetation of parts of the site have occurred. The site's designated as vacant and derelict land and now forms part of a planned wider river restoration project, including urban green space and development of active travel routes. Geo-environmental site investigations we undertook identified some shallow contaminative impacts affecting future site users, but also more significantly water environment impacts from the presence of creosote at depth. And as well as undertaking detailed consideration of these geo-environmental risks, we assessed the implications for site redevelopment and remediation, including how land contamination issues at present will constrain the nature of the proposed development. For example, not placing sensitive features such as ponds within the impacted former process areas, and looking at how removal of hard standing could lead to both risks of increased risks of exposure to future site users and contaminants in the soils, as well as potential mobilisation and leaching of contaminants into groundwater. And following this, we prepared remediation cost estimates for various future use scenarios for our clients. And this project was recognised as exemplary good practice in the 2022 Brownfield Awards. And the next part of the work we did for our clients, and following discussion about the potential for revenue generating opportunities to help offset some of the potential liabilities, we undertook further work to assess this to support beneficial reuse of the site. So this covered natural capital assessments and green finance, looking at aspects such as biodiversity net gain, carbon sequestration, water retention and pollutant attenuation. And in the second part, we looked at potential for renewable energy generation and storage. These assessments, which were undertaken by other parts of RSK, were integrated with our knowledge and understanding of the land contamination constraints on the site to develop an integrated approach. And this is illustrative of our wider approach developed to support beneficial reuse of marginal brownfield land and other degraded land, where we're seeking to balance liabilities and constraints with opportunities for future generation, where traditional developments such as housing and employment use is not suitable. Second case study I'm going to talk about relates to sustainable management of soils over the development life cycle. So RSK Geosciences and our sister company Leap Environmental have been advising clients on the reuse of excavated materials for many years. Over this time, we've developed a strategic approach to soil and excavated material management. And the main aims of this are to conserve the resource value of soils, thereby avoiding materials being classified as waste, minimizing disposal to landfill, and maximizing reuse of materials generated during construction. This assists our clients, including house builders, developers, and contractors, to reduce the potentially huge financial cost of materials handling, disposal, as well as import of virgin materials, and also helps avoid program delays. This approach supports more sustainable development, including applying the waste hierarchy and circular economy principles, and supporting pathways to net zero for the construction sector. And our approach is tailored across the development life cycle, as shown in the graphic. On an individual site level, at pre-acquisition or master planning stages, initial site surveys are used to inform a high-level soil management strategy. This considers soil as a resource to identify where it's of high intrinsic value and should be considered in development layouts and/or in supporting biodiversity net gain requirements. As the development design progresses, we undertake more detailed assessment of soils through soil resource surveys that inform consideration of options for retention and reuse as part of more detailed materials management strategies. These consider the site layout and plan changes in levels such as cut and fill. Then at construction phase, these elements are taken forward through soil resource plans, which identify how soils are to be stripped, moved, stored, protected, and placed during the construction phase. And where applicable, the regulatory options needed to support this, such as material management plans under the clear definition of waste code of practice that applies in England and Wales, or through waste exemptions or recovery permits. And these approaches can be applied to a single site over one or more or many phases, or across a client's portfolio of sites, as in the example I'm going to talk about on the next slide. So on this project, LEAP was appointed by Barrett David Wilson, BDW, to undertake a strategic review of their development portfolio in Kent, which included both brownfield sites affected by contamination and greenfield sites. A high-level review was initially undertaken to identify potential volumes of materials being generated across the portfolio. And this identified a potential surplus of up to 600,000 meters cubed of topsoil and subsoil, and an associated multi-million-pound risk item if off-site disposal to landfill of this was required. Application of our sustainable soils approach, combined with development of a live materials register and the application of industry guidance and best practice, has enabled more sustainable use of materials across the business. To date, a total of 76,000 cubes of topsoil and subsoil has been reused, and as such diverted from landfill, with associated financial savings to our client. Also, application of our ground carbon tool credit, which was developed by LEAP and the University of Surrey, has estimated an associated carbon saving of 4,000 or so tons of carbon dioxide equivalent to date by the approach. And going forward, an estimated 218,000 cubes of material is currently identified for reuse across the portfolio in the coming years, with an estimated associated carbon saving of 12,000 tons of CO2. So not only does this approach provide a huge environmental benefit, but it also contributes to BDW meeting their net zero objectives. Whilst it may be an obvious solution to share material between sites, this is not something that has been implemented successfully or widely in the industry to date. And the success that we achieved here is due to our best practice approach, close collaborative working with our client, and achieving buy-in by all stakeholders. And this project was recently recognised in the 2024 Brownfield Awards in the Best Reuse of Materials category. The last case study I'm going to talk about features RSK Geosciences support the development of a 45 megawatt solar farm on a 40 hectare restored open cast mining site. We were appointed by the developer to undertake detailed assessment of mining geotechnical and geo-environmental risks to address planning conditions and design requirements. The mining elements included undertaking ground investigation and monitoring to assess ground stability and mine gas risks, and they informed an updated coal mining risk assessment, CMRA. The mining history of this site was very complex, as well as the restored open cast with deep fill. Deep mining beneath the site had occurred in 13 seams, and there were 32 mine entries present on or near the site. And RSK Geosciences was chosen for this project because it has extensive experience assessing mining related hazards on solar PV and other developments. We designed suitable integrated ground investigations, ground gas and groundwater monitoring to cover all elements. Field work included drilling of cable percussive boreholes with rotary follow-on, window sampling and machine excavated trial pits. And all boreholes were constructed with monitoring wells to allow subsequent monitoring to be undertaken. And we also undertook extensive geo-environmental and geotechnical laboratory testing. RSK acted as designer and principal contractor under the CDM regulations, and we worked with in-house drilling contractors to provide a one-stop shop service. There were a number of important constraints that were proactively managed during the investigation, including a nearby high-pressure pipeline and encountering some very soft surface ground conditions. In a later phase, with the agreement of the developer, we were also appointed by an EPC contractor to undertake further geotechnical investigations, thermal surveys, and to undertake installation of trial piles and load testing to inform the design of the foundation solution. So what were the outcomes and benefits of this project? Also, we undertook detailed interpretation of all geoenvironmental mining and geotechnical data collected, and we prepared the CMRA and GIR ground investigation reports. And geotechnical data collected informed the design of the development. The updated CMRA report was designed to address the planning condition. This identified a potential risk of differential settlement to some access tracks and some inverter stations from the presence of buried open cast high walls and some of the mine entries. And it was recommended that the client consider relocation of these features through micrositing, or alternatively, further investigation could be undertaken and mitigation developed. We also prepared a geotechnical risk register and, as I say, provided test data from the pile load testing for use by the EPC contractor. Our initial geo-environmental assessment identified a potential need for gas protection measures for the substation buildings on site. To further address this issue, we recommended undertaking a detailed mine gas risk assessment using a lines of evidence approach in accordance with the CLARE guidance. As part of this, we undertook continuous ground gas monitoring in some of the boreholes we had installed in the previous phase and over a range of atmospheric conditions. And based on this, it was concluded the gas protection measures were not required for the buildings planned within the substation compound. So the key benefits to the client was that the reports prepared led to discharge of the relevant planning conditions without any query from the local planning authority, despite the high complexity of the site. This allowed the development to proceed without delay, and the cost saving was achieved by eliminating the need for gas protection measures for buildings. And of course, our work has supported the development of a large renewables project and beneficial reuse of a former mining site. So lastly, I'm going to touch on wider contributions by our staff on sustainability and comment on some of the future challenges for the geosciences sector. So first off, our contributions actually, in terms of best practice and sustainability, go well beyond what we do as a business. We encourage our staff to volunteer time to support professional bodies and trade associations, including JOLSOC IES, Silk, AGS and CLARE. And we also support leading the preparation of new guidance and standards. Just a few examples highlighted on here. The CLARE guidance on good practice for risk assessment for coal mine gas emissions. SOBRA guidance on assessing risk to controlled waters from land contamination for climate change, which was the winner of 2 Brownfield Awards in 2023 and led by one of our team. Work we've done for NHBC to prepare the NF93 foundation report, which looked at foundation solutions and future-proofing against climate change. And a recent paper I was involved in with colleagues from RSK Geosciences, which was featured in the IES magazine, looking at the challenges and opportunities of applying biodiversity net gain to brownfield sites. Finally, RSK Geosciences is a funder of the Syria Soil Community of Practice and an active member. As part of this and my roles at Silk, this year I led the organisation of and chaired a stakeholder workshop on behalf of those organisations to examine how future policy and regulation of excavated materials could be improved. And this led to the development of 3 position papers, culminating in a green paper with shortlisted options to consider. And the findings of this review were also featured in a recent article in Ground Engineering, which I'd encourage you to have a look at. So in terms of key future challenges for geosciences on sustainability, well, first off, climate action is obviously becoming an increasingly important issue, both in terms of mitigation, i.e. decarbonisation to support achieving net zero, as well as adaptation to respond to the effects of climate change that are predicted to happen already being felt across the world. This is going to affect all developments as well as asset management and operation going forward. And the technical challenges are particularly complex for geotechnical assessment. RSK Geosciences is at the leading edge of this, having authored the NF93 report I mentioned, and we're currently delivering the first good practice guidance for the construction sector on behalf of Syria. Second item related to the nature and biodiversity crisis. The UK is one of the most nature depleted countries in the world, and most biodiversity metrics seem to be moving in the wrong direction. Recent policies such as biodiversity net gain in England are trying to reverse this, but how can geosciences contribute? Well, we understand about soils and their behaviour, and also working with colleagues about how their properties affect the establishment of flora and fauna. We're increasingly supporting on biodiversity net gain projects, as well as rewilding for those elements. There is also an important, but as yet not quantifiable, link in natural capital terms. The link between remediation of land contamination and environmental net gain. And we expect to see increasing focus on this and increasing importance of green finance from the public and private sectors. Sorry, missed a couple of things there. On circular economy, both in terms of brownfield regeneration and suitable reuse of soils and other excavated materials, are areas that geosciences is very active in. We play a key role in supporting the development of this and supporting circular land use. We can apply best practice, but ultimately, in my opinion, a step change is needed in regulatory policy to support better conservation and reuse of excavated materials. And finally, as part of energy sector decarbonisation, the geosciences sector has a really important role to play in site assessment to support both renewables development projects and the associated transmission infrastructure needed to connect to the grid. So to conclude, hopefully I've demonstrated through this talk how geosciences can contribute a lot on sustainability. As I mentioned earlier, RSK Geosciences' vision is to provide industry-leading site assessment services to our clients to achieve more sustainable and climate resilient development and to support decarbonisation and nature-based solutions. I've explained how we're putting sustainability at the heart of our business, both in terms of our project work and reducing our emissions, and illustrated this through some project case studies. And I've touched on our wider contributions as leader in this field and some of the key future challenges that we face as society.